All right, guys. So what we have here in 4.2 is isosceles and equilateral triangles. Okay, I have the word isosceles written here for you, and there you might have some better ways. I'm not sure, but the way I kind of remember it is I saw two e's because it sounds like isosceles. I saw two e's because basically we have two sides or two angles that are congruent. Okay, in the triangle, two sides and two angles are congruent. So, like in this first one right here, we have these two sides are 4 and 4. It's an isosceles triangle. Okay. In the second one, we have these two angles are 41 degrees. It's an isosceles triangle. Okay. So that's isosceles. Okay. Um, Two sides, two angles are congruent. Now, here's the properties with isosceles. So if we know, like in this first one, we have that these sides are 4 and 4, okay? So AB is congruent to BC. If we know that, then we know that ACB is going to be equal to BAC, okay? So what we're saying is if we know these two sides are congruent, then we know these two angles are congruent, all right? So we know that, hey, maybe angle A over here is 40 degrees, then we know this angle has to be 40 degrees, all right? So that's how you're going to solve problems using these properties, okay? They're going to tell you the sides are congruent. You can use that to know that the angles are going to be congruent. Now, the same is true if they tell us the angles. In the second one, all right, we have that angle A is congruent to angle C, all right? So if they told us that AB was 10, we would know that BC is 10 also because the opposite angles from the sides are going to be congruent. So in this case, like the opposite side from this is that side and that side. Same thing here. Okay, we have that side and that side. So the sides opposite the angles are going to be the congruent sides. And it goes in reverse too. The angles opposite the congruent sides are congruent as well. Okay, so let's do some examples. All right, guys, so for this, in this example, in triangle ABC, they're going to tell us that the measure of angle A, all right, that measure is 40 degrees, okay, for angle A. Now we know that we have AB is congruent to BC because they both, AB is congruent to AC because they both have one mark, okay? This is an isosceles triangle. So from there, we know that angle B and angle C are going to be congruent. They're going to be the same angle measure. So to solve a problem like this, we know that the sum of all angles in a triangle is 180. We are going to subtract 40, okay? When we do that, we're going to get 140. And once we get that 140, that's not angle B or angle C, okay? That is the total angle degrees that are left. But we know that angle B and C have to be the same thing, all right? They're two equal parts. So we're going to take this 140 and we are going to divide it by 2, okay? And that's going to give us 70. So that is going to be the measure of angle B. And then 70 degrees is also going to be the measure of angle C because it's an isosceles triangle and those angles are opposite the congruent sides, okay? All right, guys, so for the next part is equilateral triangles, and I remember equilateral because it's all equal. So even though it's not spelled that way, equal is part of that word, and so everything in this triangle is going to be equal. All the sides are going to be equal. All the angles are going to be equal, okay? So, and again, what we're saying here is that if we know all the angles are the same measure, then all the sides have to be the same measure, okay? If all the sides are the same measure, then all the angles are the same measure. So for this, we know that in a triangle, the sum of angles in a triangle is 180, okay? So for this one, we have 3 angles and we have 3 equal parts. So think about this. If you have a pizza with 180 slices and everyone gets to eat, and you have 3 people and everyone gets to eat an equal part, then all you're going to do is take 180. Again, pizza with 180 slices, there's 3 people. Everyone wants equal parts. So you're going to take 180. You're going to divide that by 3. And when you do that, you're going to get 60. So 60 degrees is always, if you say an equilateral triangle and you say what are its angle measures, the angle measures of an equilateral triangle are always going to be 60 degrees. That would be something to jot down in your notebook, okay? So, even though the sides could change, so maybe in this triangle that we're looking at here, triangle ABC, maybe the sides are 5, okay? Now I could also draw triangle here, and you know what? It's going to be equilateral, and it might say that all the angles in there are 60 degrees. Cool. But maybe this time that side's 10. Well, then I know these other two sides are 10 as well. So, guys, the side lengths can change as the triangle gets bigger, but the angle measures are never going to change in an equilateral triangle. All right. So yeah, guys, so that's all it is for isosceles and equilateral. We'll do more practice in class. But if you have any questions, please let me know. All right, have a great day.